Section 1.2, Random Sampling. In this section, we're going to look at some techniques that are used to collect samples from your population. So in the last section, we saw those terms, looking at population versus sample. We looked at, the type of data that you might collect was qualitative, quantitative, and if it was quantitative, is it continuous or discrete? So here, we're going to look at different ways to collect that sample and, get that data, collect whatever it is you're collecting, whether it's favorite colors, whether it's heights, whatever, getting that sample of the population in a proper way that hopefully represents the whole population is always your goal. Whenever you're doing a study, you want your sample to represent the population because you want people who are going to look at your study to believe that what you're saying is true about the whole population. And, one of the biggest places where statistical studies will fall apart under scrutiny is the sampling technique. When somebody starts digging into it and it's like, oh, this is how you got your sample? Oh, well, there's no way that's going to represent the population. And from there, everything else after that just falls apart. Nobody's going to even believe it. So it's a really important part of statistical studies, how you collect your sample. And in this class, we're going to look at several techniques for collecting samples. There are other ones out there that are maybe mishmash of what we're going to look at here, but these four main ones that we're going to see in here are, pretty much the basis for any other sampling type that you're going to see. All right, so if a researcher wants to learn about the population of interest, they could do a census. We just had the census going on last year. And the idea with the census is that you're gathering observations or measurements from all of the objects in the entire population. This is time consuming. It's expensive, or could be. It's like with the census, they only do it every so many years because it costs a lot of money to get out there to every person in the country and ask information about them and their families and things. So, the census is not always easy. It can be time consuming. And expensive. So it may not be a feasible option. And this is why researchers will instead take a sample of the population and use it for their study. And there are some different approaches to taking a sample. Some are better than others, and we're going to look at some of the common techniques below. So a simple random sample, every sample is size n, whatever the number of objects in your sample is going to be, has the same chance of being chosen. And every individual in the population has the same chance of being in the sample. So essentially with this, with simple random, there's no preset way of grabbing, objects or people for your sample. It's like you're blindfolded, just picking blindly. A lot of times now what they'll do is they'll use random number generators on a computer in order to help randomly pick people out of the population. You take your whole list of people and put numbers next to each name, and then you use a random number generator to select your sample, to pick numbers that you would use to select your sample. So, a random, or I should say a sample. This is an example here of a sample. So, sample of 15 people is randomly selected from a list of the population. So nothing else really going on there. You know, the wording that you're looking for is there's going to be some mention of randomly or, you know, random, and then there's nothing else. It's like, hey, we selected these people randomly. You're going to assume it was just a simple random sample. Okay, stratified sampling. So this is a method of sampling that divides the population into different groups called strata, and then takes a random sample from inside each strata. So this is, you know, something where the way I like to think about it, you break the population into smaller groups, and then you take a little from each group. So for example, a high school population is divided into freshmen, sophomores, juniors, and seniors. Then several students are randomly selected from each group. So at the end, your sample is going to have some freshmen, sophomore, juniors, and seniors in it. The groups themselves, freshmen, sophomore, junior, seniors, these groups are what's called homogeneous. There's something special about each group. So in this case, what makes each group special and distinct? One group is all freshmen, one group is all sophomores, one group is all juniors, one group is all seniors. But as you're going through the homework and asking yourself, ooh, is this strata? You know, stratified? You want to think, are they breaking into smaller groups, and are they taking a little from each group? And if they're doing that, then it's going to be stratified. Okay, so moving to the next one here, systematic sampling. This one is the easiest one to identify because there's a number pattern involved. It's a system. You know, this method is where you pick every kth individual, maybe every third, every fourth, every 20th individual, where k is some whole number. And it's often used in quality control on assembly lines. And, you know, I can attest to this. I used to work in an ice cream plant, and, you know, we'd see the quality control people come down to the floor. They'd go over to a machine and they just grab a bar, they'd count a bunch, then they grab another bar, then they count a bunch, and then they grab another bar. And then they go back to their little place where they had all the science equipment, and they make sure that the bars were, you know, what they were supposed to be in terms of their ingredients and whatnot, up to the level of quality. So this one, if anytime you see something like, oh, we took every 100th item, immediately, you don't even got to think about it. It's not random anymore. There's a preset way that you're approaching it. So it's not going to be any of these random ones that we're going to look at. It's a system, systematic. So, for example, like every basket of berries, or every 8th basket of berries, was checked for freshness. So that's, you know, what you're looking for there when you're looking for systematic. All right, so cluster sampling. Moving to the next page here. This method is like stratified sampling, but instead of dividing the individuals into strata and then randomly picking individuals from each strata, so breaking in the smaller groups and taking a little from each group, a cluster sample separates the individuals in the groups, still doing that, and then randomly selects which groups they will use and then takes a census of every individual in the chosen groups. So whereas strata breaks it into smaller groups, takes a little from each, cluster breaks it down in the groups and then takes all from a few of the groups, not all the groups. So that's the big difference with cluster, is you're only taking a few of the groups and you're taking everything. So for example here, a study is being done on ER doctors. Each hospital in the city is treated as a cluster. Five hospitals are randomly selected and all ER doctors are polled. So in this case, you broke the city's hospitals down into groups where each hospital was its own group, and then you went to just a few of the hospitals and took all of them, all the doctors from each hospital to form your sample. So stratified, break it into groups, take a little from each. Cluster sampling, break it into groups, and then take a few groups and all from those. And here the groups for each of these are heterogeneous. You're hoping that each cluster has a good mix on its own. So you're hoping that, in a sense, each hospital's set of doctors is kind of representative of the entire population. And then by taking 5 of the hospitals, you're hoping that you get a really good mix of all the doctors' feelings. So the groups are heterogeneous. Each cluster is a mini population. At least that's your hope. Okay, so I'm going to go ahead and call this the end of part 1 for this video. Watch part 2 for the convenience sampling and then some examples.